So yesterday we did GP and see that the difference between AP and GP. In AP we get all the terms by adding a fixed term. If we keep on adding a number, we get AP. Whereas for GP, we need to multiply those terms, multiplying fixed terms. You can see a few specialities of this AP and GP before doing this one. AP, few terms, say for example, -6, -4, -2, 0, 2, for example. Even this one, 10, -7, 4, 1, -2. For AP, we can have negatives and positives, or even we can have a 0 in between. We can have negatives and positives with a 0 in between. The thing is, negative, see here, all negatives together, then all positives together. Here also all positives together, all negatives together. So in AP, while writing these terms, if we have negatives and positives, all negatives will be together, then all positives will be together. In between, there can be 0 or not. Whereas in GP, 0 will never come as a term of a GP. Why? Because if 0 is coming as a term, 0 multiplied by something, then everything becomes 0. All terms are zeros. So 0 will never be a term of a GP. Whereas in AP, 0 can be a term. Is it? Similarly, now coming to positives and negatives. In GP, can we have positives and negatives? We can, but there's a specialty. See, it can be, for example, 1 and 2, 2 2s are 4, 8, 16. Only positives, here no negatives at all. That means after a few terms we never get negatives. Even before this also we will not get negatives. Because it will be 1 by 2, 1 by 4, etc. fractions. Or it can be -1, -2, -4, -6. This is possible, is it? First time -1. If common ratio is positive, -1 multiplied by 3 is -2. -2 multiplied by 3 is -4. Again multiply. So all terms are negative. So in GP, all terms are positive, all terms are negative. In AP also it is possible. In AP also all terms are positive, all terms are negative. But in AP, few terms negative, positives, negatives and positives. In between 0. GP we said it 0 cannot be possible. Now in GP, positives and negatives. Is it possible? It is possible. But there's a specialty. What? See for example, 1. If common ratio is -2, if common ratio is negative, next term is -2. Next term is positive. -8, 16, see. If common ratio is negative, then the alternate terms becomes positive and negative. 1 into -2, -2. -2 into -2, +4. +4 into -2, -8. So in GP, positives and negatives, if it comes, it can come alternatively. Whereas in AP, we can never get positives and negatives as alternate terms. Two terms can be, but alternate terms like this, we can never get. So keep these things in mind. Positives, GP, all positives are possible, all negatives possible, and positives and negatives alternatively, that's also possible. Now, similarly, taking 3 terms, we know that if ABC are in AP, we learned it 2B is equal to A plus C. Whereas if ABC are in GP, Then the common ratio B by A, second term divided by first term, is same as third term divided by second term, or that is B squared is equal to AC. So remember it. So see that for AP, 2B is equal to A plus C. For GP, B squared is equal to AC. So remember this. This is how to check whether three terms are in AP or GP. So write it. If A, B, C are in GP, if A, B, C are in GP, if A, B, C are in GP, then B by A is C by B, that is B square is equal to AC. B square is equal to AC. So remember it, for AP, 2B is A plus C, and for GP, B square is AC. This one, inverse, if ABC, if three terms are there, the one which comes in the middle, that is called the mean, even when you arithmetic mean. The one which comes in nth, they are called the extremes. So mean and extremes. Out of ABC, the middle one is mean, these are the extremes. In AP, we can say this in words. How? Twice the mean is sum of extremes. Choice of mean is sum of the extremes in the case of AP. In the case of GP, square of mean is the product of extremes. Square of mean is the product of extremes. Other one is twice of mean is sum of extremes. So AP, twice of mean is sum of extremes. For GP, square of mean is product of extremes. So keep in mind. Now coming to exercise 9.3, the first question. Chapter first question. Exercise 9.3. Page number 192, question number 1. The question is to find the 20th and nth of GP 5 by 2, 5 by 2, 5 by 4, 5 by 8, etc. We need to find A20 and A. The 20th term and the nth term. See that whenever we get AP or GP, if the sequence is given, first we can write the first term and common difference or common ratio. So in all such questions, write A, first term A. First term A is final. Common ratio. For AP, common difference, A2 minus A1, second term minus first term. For GP, common ratio is A2 divided by A1. A2 is 5 by 4 divided by 5 by 2. Division by a fraction means multiplication by reciprocal. Division by a fraction is multiplication by reciprocal. 5 goes. So we got R is equal to 1 by 2. If R is 1 by 2, see that common ratio is 1 by 2. You can observe it. First term multiplied with 1 by 2 will give second term. Is it? 5 by 2 multiplied with 1 by 2 will give 5 by 4. Again 5 by 4 multiplied with 1 by 2 will give 5 by 8. So these are in GP. So common ratio 5 by 2. Now our formula for A n, we know A R raised to n minus 1. So A20 will be A R raised to 19. Right, directly A R raised to 19. Because 20 minus 1 is 19. That is, now put the value of A, put the value of A. A is 5 by 2. R is 1 by 2 raised to 19, which is 5 by 2. 1 by 2 raised to 19 is 1 by 2 raised to 19. 2 multiplied with 2 raised to 19 will be, so numerator 5, 2 raised to 20. Leave it as it is. Don't go for multiplying 2 20 times. 2 raised to 20, leave it as it is. Higher powers. Don't go for multiplying 2 into 2, etc. up to 20 times. Now, next is to find AN. AN is A R raised to n minus 1. A is 5 by 2. R is 1 by 2 raised to n minus 1. That is 5 by 2, 1 by 2 raised to n minus 1. Again, 2 multiplied with 2 raised to n minus 1 is 2 raised to n. That's all. Nth term will be in terms of n. It will be in terms of n. Now, question number 2. Find the 12th term of a heap. Someone is there in the class without mentioning their class. Without mentioning class, someone is there. Just give me there. I told you several times. Whenever you are logging in, put your roll number, name, and class. If class is not written, how do we know that? So next one. Find the 12th term of a GP whose 8th term is 192. Common ratio is 2. 8th term. What is first write the given data? Question number 2. 8th term is A is 192. 8th term is 192. Common ratio is 2. R is 2. What to find? Find the 12th term. We need A12. 8th term is given. Common ratio is given. We need to find the 12th term. The 12th term. So here, again we start from A8. A8 is 192. The formula for A8 is A R raised to 7, 192. Now, we know the value of R. A into 2 raised to 7 is 192. Then what is little choice of this? A is 192 by 2 raised to 7. This is it. A is 3. 2 raised to 7 now. 2 raised to 7 is 128. 192 by 128 is not 3. Not 3. Leave it as it is. Now, our aim is to get A12. A R raised to 11. What is A? 192 by 2 raised to 7. R is to 2 raised to 11. 2 raised to 11. 2 raised to 11 by 2 raised to 7 is 2 raised to 11 minus 7. 2 raised to 4. So into 2 raised to 4. Is it? 2 raised to 11 by 2 raised to 7 is 2 raised to 11 minus 7. 2 raised to 4. So it is 192. 2 raised to 4 is 68. That is the answer. Do it. Complete it. A is 1. No, leave it as it is. 192 by what? Keep it as fraction. No problem. 3072. Right. 3072. Same question. We can do. If you want, we can simplify this. Leave it as fraction. Don't go for decimals. Always keep it as fraction. Then substitute that fraction here. Simplify 2 raised to 11. 2. We can simplify anyway. See, another method without finding a also. Without finding a also, we can. I'll show you another method. Or see, A is 192 means A r raised to 7 is 192. I'm not going to do anything. A r raised to 7. Now, our aim is to find A12, which is A r raised to 11. Our aim is to find A r raised to 11. We know the value of A r raised to 7. So can we break this in terms of this? A r raised to 11 can be rewritten as A r raised to 7 into r raised to 4, is it? R raised to 11 can be rewritten as r raised to 7 into r raised to 4 because 7 plus 4 is 11. R raised to 11 means r multiplied 11 times. If r is multiplied 11 times, we can have this 7 times and then 4 times. Why do we break this r raised to 11 as r raised to 7 and r raised to 4? So that this value of a r raised to 7, this is 192 into r raised to 4 from 1. From equation number 1, the value of a r raised to 7 is 192. This is 192 to 2 raised to 4. Same thing, same answer. So, do it this way also. Again 3072. The meantime, I will take alternance. That boy is Hadi. Sure. Question number 3. The 5th, 8th, and 11th terms. The 5th, 8th, and 11th terms of an AP. Question number 3. The 5th, 8th, and 11th terms of a GP. 5th, 8th, and 11th term means year 5, year 8, year 11. P, Q, yes. 5th, 8th, and 11th terms of a GP are PQs. We need to prove that Q square is PS. Q square is PS. Q square is PS. See, year 5 is P, like in year B. AP, if A5 is given, we can write the corresponding equation A plus 4D. In AP, it is A plus 4D. In GP, A5 means what? A5 is A plus, is it A plus? A r raised to 4 is equal to P, equation of A r raised to 4, right? Similarly, A8 means A r raised to 7 is Q, equation number 2. This is A r raised to 10 is equal to S, equation number 3. We got 3 equations. A r raised to 4 A RH, yeah. Now he came with class. Now he came with class. Previously, he would have done that. So A RH to 10 ACS. The question is to show that Q square is PS. Our aim is to show Q square is PS. So LHS. Q square means what is Q? A R raised to 4 the whole square. Is it? PQS. A R raised to 7. The Q is A R raised to 7. Q A R raised to 7 the whole square. This is A square R raised to 40. Equation number 4. RHS. We have PS. P is A R raised to 4. S is A R raised to 10. A into A is A square. R raised to 4 into R raised to 10 is R raised to 4 plus 10. R raised to 14. From 4 and 5, what can we write? From 4 and 5, Q square is equal to PS pro. Now, see, start in brackets. The same question can be asked in a different way. If Q square is PS, we did it before. Q square is PS. If B square is AC, ABC are in GP. So if Q square is PS, what can we write? We can write or prove that P, Q, S are in GP. The same question can be asked in a different wordings. Prove that PQS are in GP. To show that PQS are in GP, Q square is, we need to prove Q square is PS. So same question. So make it as a no. This Suleiman, yesterday also he came late for only. He's coming for attendance only. Q square. Now, question number 4. Question number 4. The fourth term of AP GP. See the wording? Roll number 33. Suleiman, yesterday also you came late, just before 10 minutes. 4. The fourth term of a GP is square of second term. Fourth term given. Fourth term is square of second term. Fourth term is square of second term. And first term is minus 3. So A, first term, A is minus 3. Fourth term means A4. Fourth term is square of second term. So A2 square of second term. Fourth term is square of second term. So fourth term, A4 means ARQ. A2 is AR, the whole square. This is ARQ is equal to A square R square. How to simplify it further? A and A square cancel. A and A square cancel. R square and 1, this 3 cancels. 1. What is left out? We got R is equal to A. Therefore, A is equal to R is equal to minus K. A and R both are equal. A is given as minus 3. Therefore, R is also minus 3. Now, what's the question? Determine the seventh term. Our aim is to find A7. So A7 is A R raised to 4. A is minus 3. Minus 3 raised to 4, which is minus 3 into. No, A is 6. Not 4, 6, it is 6. Minus 3 raised to 6. Multiply minus 3 6 times. You'll get a positive number. Then multiply minus 3 7 times. Multiplying minus 3 7 times, whatever you get, that's the answer. Minus 3 multiply 7 times. What do you get? That is the answer. No one multiplied. Multiplied. Minus 3 7 times. So the answer will be negative. If you are multiplying 7, because this is minus 3 multiplied minus 2187. Is it? Yes. Minus 218. That's it. Now, question number 5. We'll do the first 2 bits. Question number 5. Which term, see, question number 5, the first bit. 2 root 2 4. 2 root 2 4, etc. And the last term is given as 1 term because specifying it. Or which term means number of terms or last term. Yeah. Whenever GP is given, the first thing is writing A and R. What is A? A is 2. R is 2 root 2 by 2, which is root 2. We got A now. A and 128 means A R raised to n minus 1 is 128. A is 2. R is root 2. Raised to n minus 1 is 128. Take 2 to other side. Root 2 raised to n minus 1 is 128 by 2. Is it? (128 by 2). Again, why is Jawad came now? 5 minutes. Right. So now this is root 2. See, actually, root 2 means 2 raised to 1 by 2, is it? So root 2 raised to n minus 1 means 2 raised to 1 by 2, the whole raised to n minus 1, which is 2 raised to n minus 1 by 2. So root 2 raised to n minus 1 means 2 raised to n minus 1 by 2. This is 64. See that our aim is to find this n. And this n is in the exponent with a base 2. So we have to write the 64 also as a number with base 2. See, 64 can be written as 8 square. But in 8 square, the base is 8. We need the same base, then only we can equate it. So this is 2 raised to n minus 1 by 2 is 2 raised to 6. Because 64, if you are factorizing 64, we can get 2, 32, 2, 16, 2, 8, 2, 4, 2, 1, 2, 3, 4, 5, 6, 8. We'll get 6 2's. So from this we can write n minus 1 by 2 as 6. because bases are equal. See that 64 we made the bases 2 not as 8. Why did we make bases 2? Because left hand side base is 2. So n minus 1 is 6 into 2. N is 12 plus 1, 13. N is 13. N is 13. We'll do one more question and stop. B bits. Root 3, 3, root 3, etc. The question is root 3, 3, 3 root 3, etc. N is given us 729. Start doing it. Again, what is A? A, the first term is root 3. R is 3 by root 3. 3 by root 3 can be simplified. This is root 3. Because 3 can be written as root 3 into root 3, is it? 3 is root 3 into root 3. So 1 root 3 cancels, left out is root 3. So this is 729. A is root 3. Root 3 raised to n minus 1 is 729. Root 3 multiplied by root 3 raised to n minus 1 is root 3 raised to n is 729. Root 3 raised to n is 3 raised to n by 2. 729, factorize it. Factorizing 729. How many 3's? 3, 243, 281, no, 3, 81, 3, 27, 3, 9, 1, 2, 3, 4, 5, 6, again 6. This is 3 raised to 6. N by 2 is 3 raised to 6. This implies n by 2 is 6, n is equal to 12. That's it. Anything else? So you'll continue tomorrow. Anything else? Nothing. So we will. So where one? Where one? Which one? Which one you're talking about? Goes from n minus 1. Root 3 into root 3 is n minus 1. X into x raised to n minus 1. That's a good question. See, x. This will be x raised to n only. Why? 1 plus n minus 1. So root 3 into root 3 raised to n minus 1 is, if I multiply, this will be root 3 raised to n. I hope you got it. X into x raised to n minus 1. So root 3 into root 3 raised to n minus 1 means 1 plus n minus 1. So it is n. Anything else? Have I taken? So attempts I have taken. I have taken attempts. That is what I feel. Yes. Yes. So see you tomorrow.